Welcome to your first pre-lab on abstract models. So today we're going to learn about how to code an abstract model into Pyomo. So our video goals for today are going to be to review the difference between concrete and abstract models. We're going to code our first abstract model, and that's going to be split up into several parts. So part one, we're going to look at sets, parameters, and data files. Part two, we're going to learn about decision variables. Part three, we're going to code up our objective function. Part four, we're going to spend some time looking at how to code sets of constraints. And then we're going to conclude with actually running the abstract model. And then the final part of this pre-lab will be to look at interpreting the solution output. So just to review, we're going to quickly cover the difference between concrete and abstract models again. So our concrete models, these are the types of models we've already coded in class, contain everything that we need to know about our model is hard-coded into the model formulation. And these concrete models only use one file, a single .py file. So they might look something like this. This was our pre-lab for lab 3, and it was the CSL model file. And if you look really closely, we can see a whole bunch of numbers in this model file. These numbers are parameters, and we can see that they're hard-coded in there. So if we wanted to change them, we have to go into our model file, find everywhere we used a value, and change it. Our abstract models are going to separate our model parameters from our model formulation. And we end up having two files. One is our model file, which kind of acts as a recipe or instructions, and it looks like Python code or Pyomo code. And then our other file is called a data file, and it has a .dat extension. And this file stores all the parameter values. And what a data file does is it allows us one quick, easy place to access all of our model's information. And we can change that information in one place, and everywhere that information is used in the model will be updated. And to briefly go over some of the terminology we're going to see today, we're going to review some brackets. So we have square brackets, parentheses, and squiggly brackets. Today we're going to see both square brackets and parentheses make an appearance. You're going to hear the word dot a lot. It's a fancy word for a period. You might hear star or times. For that, we'll be using the asterisk symbol. And then we have some terminology specific to the data files. So you might hear me say colon equals. That's literally a colon followed by an equal sign. If you don't know where the colon is, it's next to the L, and it requires the shift key. And then the equal sign is up there next to the backspace. And we also use semicolons in data files. They look like what you see here, and they're also next to the L. They're just if you press that button, you'll get a semicolon. So before we start coding our abstract model, I wanted to review our CSL concrete model so we can see the concrete version. Then we'll see sort of the abstract formulation of it, and then we're going to code that abstract formulation. So just to review the CSL technician problem, if you're just joining us for the very first time. In this problem, we have a series of months, and as the months go on, we need more and more employees in order to meet our required hours of technician hours. And to meet these technician hours, we have skilled or experienced technicians. And we also have the opportunity to train new technicians. And our experienced technicians make $2,000 a month. Our trainees only make $1,000. Our skilled technicians, if they're working full-time, can provide 160 hours per month. But unfortunately, 5% of them quit each month. And we have 50 of them right now. Our trainees, if one is being trained that month, they require 50 hours of experienced or skilled technician time to train them. And while they're being trained, they don't provide any productive work for us. So our task was to formulate a linear program to represent this model problem. And we wanted to minimize CSL's cost over the next 5 months. So our original concrete formulation looked something like this. And we'll look at this in comparison to our concrete code. So we had in our Python file, we had many lines that were declaring our decision variables, and at the same time, those also provided our non-negativity constraints. We had our objective function, which we were basically adding up all of our labor costs. We had one set of constraints that was making sure that we met the demand for each month. And then we had one set of constraints that was basically calculating the number of experienced technicians we had at the start of the next month. And then we had a few lines of code that ran the model. So if we were to write our CSL concrete formulation and an abstract formulation, it might look something like this. And this should be familiar to you. You've seen it in class. Our decision variables are going to be defined the same way. Our objective function, when we wrote it concretely, we wrote out this big long summation. If we wanted to write that more succinctly, we could actually use a summation sign and say that we're going to sum over all of our months. And for every single month, we're going to say $2,000 times however many experienced technicians work that month, plus $1,000 for our trainees that are working that month. And then our first set of constraints in our concrete model, we could kind of rewrite those using a pattern. So in this first set of constraints, we see that every single constraint looks pretty much the same, except for we're changing the subscripts. And then we also see that we have these parameter values on the right-hand side, these required hours for each month. Those numbers are different. So in our abstract version, we're going to replace those numbers that are different, each of those required hours, with a parameter. And we're going to call it hours required sub t. So we can rewrite those 5 constraints with this one line in our abstract model that says 160 times the number of experienced technicians for that month minus 50 times the number of trainees for that month is greater than or equal to our required hours for that month. And then we have this little part on the end that says, and we have one of these constraints for every single one of our months. And then we have another set of constraints that's basically calculating how many experienced technicians we have at the beginning of each month. So our abstract model, the first constraint that's just capturing our starting number of technicians looks the same, but the last 4 we can write more succinctly because they all follow the same pattern. We can say, well, the experienced technicians in month T is equal to 0.95 times the experienced technicians in T minus 1, or the month before. So that first chunk basically says 95% of our experienced technicians stay on. And then we're going to add up, or add to that the number of people we trained last month, so the number of people we trained in T minus 1. And we have one of these constraints for each of our months starting in month 2 through 5. And then we have our non-negativity constraints, which could just be represented as T sub T and then E sub T are both greater than or equal to 0. And we have one of those non-negativity constraints for all T that are elements of months. So this abstract formulation is not really quite as abstract as it could be because we still see a lot of parameter values in there. And we also see we're sort of using this set of months. And we didn't really specify that anywhere. So to be a good abstract model, we want to specify everything. So part of an abstract formulation also specifies the sets. So in this formulation, we have a set of months that we're using. So our formulation should talk about the months. And then we also have some parameters. So one parameter that we know about is this hours required sub t. So we want to specify that over in a parameters section. So in our parameters section, we can write something like hours required sub t, and then give it a definition. It equals the number of hours required in month T. And we have one of those for every single month. But then we also want to be able to remove all these hard-coded values from our formulation so that we're free to put in any value we want. So for example, this 2,000 in front of our, or that represents the cost of our experienced employees, we can extract that as a parameter. Maybe we'd call it salary EXP, and it could represent the salary of an experienced worker. Once we create that parameter, that salary EXP value is going to be used in place of 2,000. And we can see that being used here. And then we can do the same thing for this $1,000 or the salary of a trainee. We can make a parameter for that. And then everywhere we need that salary for a trainee, we'll use salary trainee instead of the number 1,000. So after including those two new parameters, we see them being used in our objective function. And then we can do that for all the other parameters we see in our model. So we see some parameters down here that are related to the number of hours our technicians can work. So our hours for experienced workers, we could make a parameter for that. And the hours that a trainee requires, we could make a parameter for that. And instead of hard coding those values, we can use our sort of parameter placeholders. And then there's a few more parameters we should take care of. We should take care of the number of starting experienced workers. And then we can also replace this 0.95. And we can use something like a quit rate, for example. And we can say 1 minus the number of people that quit. That's going to be who's left. And we can use that in our model formulation. So now if we look at our model formulation, we see that it has no numbers anywhere in it. So this is an example of a really nicely formulated abstract model. So let's get coding this. The first thing that we're going to do is create an abstract model file using Spider. So let's go do that. So you can see here I have Spider open. To create an abstract model, I create it the same way that I would create a concrete model. I go to File, I say New File, and then I want to save it somewhere. So I'll go and I'll say Save. And when I save this file, I want to make sure that I'm sort of cognizant of where I'm saving it, because I want to put my data file, which we'll be creating later, in the exact same folder. So I'm going to call this file maybe CSL abstract. And then I want to make sure it gets saved as a Python file. So I'm going to go down to supported text files and choose Python file. And we'll save that. And you should see that its name ends with the .py extension up here. So this is the starting place. So in front of you, really tiny on your screen, and I don't expect you to be able to read this, is our entire model file that we're going to be coding today. But some of the sections are important. So this top section is basically creating a model file and defining sets and parameters. Then there's a few lines that create all of our decision variables. We have some lines that create our objective function. We have a few lines that create all of our constraints. And then down towards the bottom, we have some code that's basically taking our model definition and merging it with our data file that we're going to create a model instance. And then the last few lines of this model file basically solve the instance that we've made. So we're going to start off coding our sets, parameters, and our data file. So if we look at our CSL abstract model, we're going to be doing everything in this red box over here. We're going to create our sets, we're going to create our parameters, and then we're going to put the information for those parameters into a data file. So looking at this entire model file, this next section is going to talk about these first 7 lines. And here we can see them a little bit bigger. Now, if you don't have Spider and you don't have Python installed on your computer, GLPK installed on your computer, I recommend you go to the folder linked in the description of these videos. Download Pyomo Hello World with Google Colab. Put it into your own Google Drive. If you open that up, what you'll see is just sort of a standard file that you can always start with for all of these tutorials. It's going to install Pyomo for you, install GLPK for you, and then what you're going to do is replace sort of the code that we're generating in Spider. You'll put your new code in this section here, and then when we're solving the model, you'll be replacing these lines down here. So this is a nice starting point if you don't have Python already installed on your computer. And additionally, a little bit later in the video, when it starts making data files, I'll also show you how to make a data file in Google Colab as well. So let's start off with the very first line. This from pyomo.environ import star. So here he is. He should look familiar to you. We start off every single one of our Pyomo models this way, whether it's concrete or abstract. And the translation of this line is basically saying, hey, Pyomo's already created a bunch of really useful functions for writing linear programs. Let's import them so we can use them. And the functions we're going to be using today, one is a new one. It's called abstract model. We're going to use the set function, the param function, and then others that you've seen before, but we're going to be using them a little bit differently, are var, objective, constraint, and the solver factory. We'll use the solve function and the display function. So after your import statement, the very next thing we need to do is create a model. So let's look a little bit more closely at this line. This line reads model equals abstract model and then parentheses. The basic translation of this is create a model object and name it model. And in particular, this is an abstract model, so this type of model is going to be looking for a data file. And an abstract model, the model basically acts as instructions on how to make a model. So we're basically going to be providing a bunch of instructions on how to make a model in this file. Coming up next, let's define our sets. So in our abstract formulation, we're going to be coding this line here that says sets, and then we have the set of months. So looking more closely at these lines in Pyomo, first we see model.months. Here we're basically adding a component to our model object, and the component is called months. And you'll see that it's written in all capital letters. It's a fairly common convention to name sets with all capital letters. One of the reasons is because it makes them really easy to identify in our code. So after we say model.months, we say equals set. Set is a type of object in Pyomo, and it represents a group or a list of items. So this whole line is basically saying, add a set to my model, and let's call this set months, all written with capital letters. Now notice that this line does not specify any of the actual months. Like we don't know if we're doing this for January, February, March, or month 1, 2, and 3. It doesn't tell us any information about what the months are. That information is going to go in our data file. So after we've listed all our sets, and this particular model only has one set, we can move down here to specify some of our parameters. So let's look at the salary exp parameter. And we can see him in our CSL abstract formulation. He's the second parameter, so we're going to skip hours required sub t for a few minutes. So when we're specifying parameters that have a single value, we do something like this. So we have model.salaryexp equals param. This model.salaryexp part basically says, hey, I want to add a component to my model, and I'm going to call it salary exp, or salary of an experienced technician. And this param part of the line, param is a parameter object type in Pyomo, and parameter objects store data values. So this whole line reads, I want to add a parameter to my model, and I want to call the parameter exp, salary exp. And again, notice that we didn't provide any value for the salary of an experienced technician. We basically just said that this value exists, but the actual value, we're going to store it in our data file. And you can see there are 6 single value parameters in this model. We can see them listed here in our abstract formulation. And they're all coded very similarly. They all start with model dot and then the parameter name. And it's important that we give parameters human readable names that describe what they mean. So we want to try to come up with a short name, but something that when we read it, we know kind of what it means. And then also notice that in our model file, every parameter has a detailed description of what they're for. And some of these get cut off in this view, but they're nice long descriptive comments about each parameter. And again, we still don't know what any of these values are. That information is going to go into our data file. And then lastly, let's look at this hours required parameter. In our CSL abstract model, the hours required parameter is the only one with a subscript. So we see hours required and then it has a subscript T. This parameter has a subscript because every single one of our required hours, or every single one of our months, has a different number of required hours. So our parameter definition says, hey, there's actually a lot of these parameters. There's one for every single month. So again, notice that there's a subscript for this parameter. And we've also specified what the values of those subscripts are. So those subscripts take on the value of every single thing that's in our month set. So this one line in our problem formulation basically says create 5 hours rec parameters. Create one for every single month. So if we look at the Pyomo version of this, it looks something like this, where it starts off very similarly. We have model.hoursRec. This part basically says I want to add a component to my model, and I want to call it hoursRec. The hoursRec item that we're adding is a parameter object. So we're using that same param function. But this time, we're passing something to this param function. So when we pass a set to our param function, it basically says, make a parameter for every single value in the set that I've passed you. So this whole line reads, add a set of parameters to my model called hoursRec, and make one for every single element in my month set. So later on when we make an instance of this model, Pyomo is going to create 5 model.hoursRec parameters, and they're going to look like the following. They'll be model.hoursRec square brackets 1, all the way through model.hoursRec square brackets 5. So it's going to make 5 different hoursRec parameters. And one thing to notice, when we defined that hoursRec parameter, we used model.months. Model.months is the set that we defined earlier. So we're using that set we defined earlier to help define our parameters. So the next step is basically adding all these parameter values and set items into our data file. So let's start by creating a data file in Spider. Okay, so I'm here in Pyomo, and I have my model file that I've made. And so far we've looked at lines 1 through 17, and now we want to basically create the data file that goes with all these parameters and sets. So the easiest way to do this is to go up to File, New File, and then we're going to save this file. So we're going to go to File, Save. And we want this file to be in the same folder as our abstract model. And I'm going to save this file with the name CSL data. And I want the extension to be .dat. So I'm going to type that there. And then under supported text files, if you go all the way down to the bottom, you're going to choose all files. And what that's going to do is it's going to use the extension that you typed in. So the extension is .dat. And we'll save that. And I should be able to see my CSL abstract.py file. And then I also see CSL data, and I see that it has the extension .dat. And I'm going to delete all these comments that show up at the beginning of this data file because sometimes they can cause you issues. And then another nice trick that I like to use is it's really nice when you're coding your data file to be able to see your model file at the same time. So if I go up to this tab and I right click on it, if you click split horizontally, it's going to open up another window for you where I can see my abstract model file on one pane and then my new data file that I'm typing over on the other pane. And you can see them side by side. And this is really helpful because we have to make sure that we spell all these names of our parameters and our sets. We have to make sure that we spell them the same in our data file. So it's nice to see them side by side. So back to our presentation, we've looked at these first 17 lines of our model file, and over here on the right we see the completed data file. So let's look at this data file line by line. So the first thing here is we see that in our model file we have a set of months, and then we see that we've defined that set of months in our data file as well. So the first part of our description in our data file is the word set. This tells Pyomo that we're about to provide information for a set. And this comes with a warning. The warning is that the data file uses the word set with all lowercase letters, but in our model file, when we use the word set, it has a capital letter S. So our data file, all lowercase letters. Then we see that we've used the word months in all capital letters. That follows exactly like what we did in our model file, except in our data file we don't include the model dot part of the name. So we see set months colon equals. So colon equals is kind of Pyomo's way of saying equals. And then we see a list of months. So here we've used months as numbers. We could have used months as words, but then it makes some of the math that we're going to do a bit later a little bit tricky. So anytime you can use numbers in a set, it's usually pretty helpful. So here we have a space-delimited list of elements in the month set. So we're basically saying our set of months is going to have the values 1, 2, 3, 4, and 5 in it. And then last but not least, we want to make sure that we don't use commas to separate our list. It's very tempting to say 1, 2, 3, 4, 5, but that's going to make Pyomo extremely angry at you. So we can separate the elements in our list by spaces and by tabs, but don't use commas. And then last but not least, but very important, we need to end every single set with a semicolon. So moving down, we're going to check out how to specify one of our parameters, our single value parameters in a Pyomo data file. So this first part, param, says, hey Pyomo, I'm about to tell you about a parameter value. And again, we see a warning here. The warning is because in our data files, param is all lowercase, which is opposite of our model files where we have to capitalize the P. After the word param, we're going to tell Pyomo which parameter we're specifying. And this name has to exactly match one of our names in our model file, but we leave off the model dot. Then we have colon equals, which again just acts like an equal sign, but you definitely need to use colon equals. Then we provide the value of that parameter. So here, our technician's salary for our experienced technicians is going to be $2,000. And then finally, it's very important to end every single parameter definition with a semicolon. So that was a quick look at one of our parameters. The other 5 parameters are coded much the same way. Where we see we start off with the keyword param, then we use the same name from the model file, but we drop the model dot. Then they all have colon equals and what the value is, and they all end with semicolons. And then moving on to our hours required parameter. This one is a slightly more complicated. But one of the things I want you to see is that when we defined our hours required parameter in our model file, we used the set model.months. When we're defining our when we're defining our hours rec parameter in our data file, we need to make sure that we look at the set of months that we specified in our data file, and every single one of those months that we specified has to show up in our hours required parameter definition. So here we specified that the months were 1, 2, 3, 4, and 5. And so we see that we've specified values for months 1, 2, 3, 4, and 5 in our hours required parameter. So taking a closer look, parameters that have multiple values, like hours required, still start with the same keyword param. We still use the same name from our model file without the model dot in front. We still follow it with colon equals instead of like an equal sign. And then we basically have a list of key value pairs where the first value is one of our months, and then the second value is the hours required for that month. So this first line of our hours required parameter says the number of required hours in month 1 is equal to 6,000. And Pyomo is actually going to store that. Like if you ever wanted to use that precise value, you would reference it with square brackets. So it would be model.hours required, and then in square brackets, the number 1. And we see we have one value for every single one of our months that we listed. And more importantly, we can only use values that are in the month set. So we can't specify any values in this hours required parameter unless they show up in our month set. And finally, like all parameters and sets, we have to end the definition with a semicolon. That lets Pyomo know that we're done talking about the hours required parameter. Real quick video on how to make a .dat file or a data file if you're using Google Colab. So let's say I wanted to really quickly make myself a .dat file. I could go into sample data. Now remember that these files are going to disappear after you're done, so this is not the best place to do this. And I could go new file, click that. Here, I can give my file any name I want, so I could call it CSL abstract data.dat, and I press return. Now I've got myself a .dat file, and if I want to edit it, I double click, and it's just this blank canvas. So I've already typed my .dat file elsewhere, but I could have just as easily typed all this information here. It's gonna save automatically. Once it's in there, we can close it up. We open it back up, we see it's all nicely saved. If I want to use that in my model, I'm going to right click and say copy that path. Down in where I'm loading the data, I'm going to give it that file path that I just copied, which looks like this, and that'll use that data file for you. So there you have it. We've taken care of this whole left-hand side of this abstract model where we've formulated our sets and our parameters. And we've encoded those values into a data file. So now we're going to move on to our decision variables.